Welcome to the Knowledge Academy Online. This demo is concerned with the role of ACOKnowledge in promoting knowledge that is relevant to the paradigm shifts created by the Fourth Industrial Revolution and much more. A picture is worth 1,000 words. And that's why we prefer videos to textbooks. Only when you know the why of things can you master them. Why is ACOKnowledge so thrilled about the Fourth Industrial Revolution? What is so different about technology-led progress this time round? What are disruptive and exponential technologies? Why do near-zero marginal costs create so much wealth? Why is there so much inequality in an economy of abundance? Why should we be so optimistic about the future? The Fourth Industrial Revolution is the social and economic change driven by mobile supercomputing, ubiquity, intelligent robots, autonomous vehicles, neurotechnological brain enhancement, genetic editing, and much more, and the evidence of disruptive changes in everything around us that happen at exponential speed. The exponential growth of science and technology in the Fourth Industrial Revolution contrasts with the slow but important advances of mankind 13,000 years ago. It should also be understood that there are enormous overlaps between the periods in which great transitions occurred, and that there are still today peoples who have not yet begun the first agrarian revolution. The Fourth Industrial Revolution began at the beginning of this millennium, and is global. The figure illustrates some of the technologies characteristic of the Fourth Industrial Revolution. Mobility, decentralization, and the low cost of equipment, including demonetization and dematerialization, are important features. In the past few decades, inequality of income, low wages, and unemployment have been a negative aspect in many countries, despite very low inflation. This figure illustrates the portion of the highest thousand income in the Anglo-Saxon countries, from 1910 to 2010. The share of the top 1,000, or 0.1% of the highest incomes in total income, has risen sharply since the 1970s in all Anglo-Saxon countries, but with different magnitudes. The very high wages of the super CEOs, superstars, and tech entrepreneurs have been pointed out as a major cause for this inequality. Automation, robotization, artificial intelligence, and paradigm shifts are displacing workers from more traditional jobs. This is why there is an increasing interest in universal basic income. Radical change is the name of the game. Old folk may resist, but the young generations adapt very quick. But there is more change to come soon. A quantum computer is a device that performs calculations making direct use of properties of quantum mechanics, such as superposition and interference. The most developed quantum computer today is D-Wave 2, which works with 512 qubits of information. The main gain of these computers is the possibility to solve algorithms with huge speed. DNA molecules are ideal for making a molecular computer. They are efficient and very compact. For comparison purposes, a DNA tape contains all the information for a cell to remain alive, and yet the tape constitutes only 0.3% of the volume of the cell nucleus. DNA accumulates 100 trillion times the information stored in today's most sophisticated computing systems. In a DNA computer, a stratospheric number of molecules, somewhere around 10 to the 10th power, can work simultaneously to perform a computation. Only recently, with the emergence of the modern computer, has artificial intelligence gained the means and critical mass to establish itself as an integral science with its own problems and methodologies. Since then, its development has extrapolated classical chess or conversion programs, and involved areas such as computer vision, speech synthesis and analysis, fuzzy logic, artificial neural networks, and many others. A smart grid is an electricity supply network that uses digital communications technology to detect and react to local changes in usage. An autonomous vehicle is a vehicle that is able to sense its environment and navigate without human intervention. Genome editing is a type of genetic engineering in which DNA is inserted, deleted, or replaced in the genome of a living organism, using engineered nucleases, or molecular scissors. The ultimate goal of tissue engineering is to create a three-dimensional scaffold, containing cells that can be implanted in the body, to cure a disease, or repair a defect. Regeneration is the ability of cells to renew themselves. Molecular self-assembly is an important aspect of bottom-up approaches in nanotechnology. Using molecular self-assembly, the final, desired, structure is programmed into the form and functional groups of the molecules, being referred to as a bottom-up manufacturing technique, in contrast to the top-down technique, as lithography, where the desired final structure is carved from a larger block of matter. Graphene is an allotrope of carbon in the form of a two-dimensional, atomic scale, hexagonal lattice, in which one atom forms each vertex. It is the basic structural element of other allotropes, including graphite, charcoal, carbon nanotubes, and fullerenes. It is an excellent conductor of heat and electricity, being almost transparent. It is the most resistant material known, being 100 times stronger than steel. Amita material is a synthetic composite material with a structure such that it exhibits properties not usually found in natural materials, especially a negative refractive index. These nanostructures are designed to disperse light, but can also be used to disperse microwaves, sound waves, and the little-known T-rays. They can, for example, make things invisible. In recent years, 3D printers have become financially affordable for small and medium-sized businesses, taking prototyping to the desktop. In addition, it is possible to simultaneously deposit different types of materials. The technology is used in various branches of production, such as jewelry, footwear, product design, architecture, automobile, aerospace, and medical development industries. Thanks to the advances of the 3D printing, it is possible to print everything from prosthetics to heart, kidneys, and other vital human organs. Researchers are now working on the use of this technology in a molecule-making machine to simplify complex chemistry. Some of the products produced by 3D printing are shown here. We, at ACOKnowledge, very much believe in sustainable development, and that, in an economy of abundance, there is enough for all. However, there are massive opportunities for those who acquire the new knowledge to be active players in the fourth industrial revolution. Please log on to ACOKnowledge.org to learn more about the fourth industrial revolution and much more.